move on to muscular endurance next. And muscular endurance is simply defined as the ability to perform repeated muscle contractions against a submaximal resistance or to sustain a contraction over time. So there's a number of common exercises or tests that are used to assess local muscular endurance, including the partial curl-up test. Here the athlete would perform curl-ups, typically on a mat on a flat surface, at a rate of about 20 curl-ups per minute, up to a max of about 75, or they could perform the max number of curl-ups within a given time period, such as 1 or 2 minutes. There are also a number of specific push-up tests, including the test that you see down here, performing the max number of reps of push-ups in 2 minutes, or simply performing reps to failure. There's also performing movements where a contraction is sustained over time, such as planks. And also another common one of local muscular endurance is the YMCA bench press test, where typically the athlete would perform as many reps as possible using a submaximal load for the bench press. And that's typically, I think, 45 pounds for females and 85 pounds for men. Also, we can have an athlete perform max reps performed at a given percentage of their 1 repetition maximum. So for example, we could have them perform the bench press exercise at 75% of their 1 RM, which in most individuals is going to correspond to their 10 repetition maximum. But we're going to have them basically perform a max number of reps until fatigue at a submaximal load in order to determine their local muscular endurance. All right, looking at this table next. Looking at strength, power, and muscular endurance of 3 athletes performing the bench press exercise. And you can see down here below, strength was determined by performing a 1 RM bench press test. Power was determined as the athlete performing the 1 RM test as explosively as possible. And muscular endurance was determined by the greatest number of reps that could be completed using 75% of the 1 repetition maximum for the bench press. So looking at the values here, for athlete A, B, and C. Which athlete is the strongest? So again, that's pretty apparent. If we look at the numbers there for muscular strength, we see that athlete A is the weakest, whereas athletes B and C have equal muscular strength. They're both lifting 200 kilograms in the bench press. Which athlete is the most powerful? Again, we look at the power here. Athlete A lifted 100 kilograms, 0.6 meters in about half a second. If we calculate power, as typically expressed in watts, this athlete is generating over 1,100 watts in power. Athlete B, half of that, as they're taking twice as long to lift the 1 RM load. And again, that comes up to 588 watts, and athlete C performing the same power output as athlete A. So we could say that athlete A and C are equally as powerful, whereas athlete B is the least powerful in this example. And then for muscular endurance, which athlete has the greatest muscular endurance? Athlete A performing 10 reps at 75% of their 1 RM load. Athlete B, 10 reps at 75%. And athlete C, only 5 reps at 75%. So based upon that, we could say that athletes A and B are equally or have equal muscular endurance, whereas athlete C has lower muscular endurance. All right, moving on to our next measure of athletic performance, and that is maximal aerobic power, which represents the maximal capacity of the anaerobic energy systems to produce energy, or ATP. And by anaerobic energy systems, I'm focusing on glycolysis and the ATP phosphocreatine systems. These tests are typically 30 to 90 seconds in duration, with the most common measure of anaerobic power or capacity known as the Wingate cycle ergometer test. And here's a short video for you to watch in your own time of a former professor of mine actually describing the Wingate cycle ergometer test and some of the measurements and some of the data that we can get by performing a Wingate test in athletes. So output or data from a Wingate test may look something like this. Again, this test is 30 seconds in duration. It's basically an all-out sprint on a cycloergometer. Within the first 5 to 6 seconds, peak power is achieved. In this athlete example, peak power is approximately 1,000 watts. And then as athlete begins to fatigue, we see that power drops off over the next 20 to 25 seconds or so. We can calculate average power over the entire 30-second test. We can measure what is known as power drop, which is the decrease in power output from peak power value to the minimum power value. We can also calculate anaerobic fatigue index, so basically looking at power drop, but expressing that as a percent decline in power output, again from peak to the end of the test. This is another example of a Wingate test. Again, we're looking primarily at power output in watts. We see power here in the pink line. You see how it peaks here within the first few seconds of beginning the Wingate test, drops off, and the athlete is trying to prevent a large drop-off in power over the course of the 30-second test. And then you see how the cadence or RPMs also are affected by performing this high-intensity fatiguing test, starting at high, around 100 RPMs, and then dropping off to about maybe 60 to 70 RPMs towards the end of the test as the test becomes more difficult. Another common measure of anaerobic power or capacity is a 300-yard shuttle. This requires a lot more setup. In this example, we would have basically two judges that are spaced about 25 yards apart. In the first trial here, the athletes would sprint basically from the start line to the next line, which is again 25 yards, completing 6 round trips here. So 25 yards up, 25 yards back, that's 50 yards, completing 6 round trips, 50 yards each for a total of 300 yards. Basically covering this distance as quickly as possible. Typically the athletes are given a 5-minute rest, and then that test is then repeated again, performing 6 round trips, and the average of trial 1 and trial 2 is used as the athlete's overall test results. Here's a short video of showing the 300-yard shuttle test in action. This is in an indoor facility. Again, the lines are marked off, so we know that this is 25 yards from cone to cone. The athlete is going to sprint to the first cone, sprint back, and again, that's 50 yards in total, and then they're going to do that 5 more times for a total of 6 round trips, and basically looking at time to completion of the 300 yards.